All right, so last time where we left off, we were making a program on simplifying radicals, and we did most of the mathematical parts and everything. As you can see here, it's not there's a ton of lines, but if you follow me and know what's everything's going on, I'm pretty sure you'll follow along. So back then, if you need to watch part one to get all this information, because I'm not going back there. If you need to watch part one, go watch it right now because it's probably uploaded. So now to this in this part, we're going to finish up the mathematical parts of our program and finish up the program coding itself, and then we're going to test out the program. So let's go back to where we left off. So last time we answered off with using an imaginary number answer. So now we still have to add a bit of more things to it. So go to program one. One, if one is go to second math, unequal to or unequal to. Go to second catalog ABS alpha r. So if 1 is not equal to the absolute value of alpha r, what we prompted for, program 2, then output 1 comma 1 plus second negative. Make sure not put that comma on the second one. 1 plus negative comma alpha plus, which is a quotation mark, second and x squared to make the square root sign, and press enter. Okay, so we'll just say like, okay, this is where the radical goes. So output. So the next thing we're gonna do is pretty long, but just bear with me. So output 1 comma 3 plus second negative comma alpha r parentheses, create another parentheses, so 2 parentheses, r second math is greater than 0 minus r, well no, go back there, alpha r is less than 0. Close that out. I know. So basically what we've done here is if 1 is unequal to the absolute value of r, then output 1 comma, then we're going to output the square root of r times the distribution property of whatever r is times r that is greater than 0 and minus r that is less than 0. I know it's a bit confusing, but I'll show you what it means later. So program press 8, okay? Or you can just go to program, then scroll down to pause. So enter. And now go to program, now IO, and scroll down to clear home. And then program 7 end. So basically, it shows the answer and it's waiting for you to press the enter key so you can write down the answer and then press the enter key. And then once you do that, it clears the screen and bam, end. And there's no more to it. That's about everything that's about every line of code that you need. So it's a fairly lengthy piece of program. It's about well, we can check it. So to get out of the program, do not press clear because that will clear a command. So second quit, second mode, and then yeah. Now go to second memory and go to memory management. Let's see how much it is. For when I'm using the emulator, I have like the maximum amount of RAM free. So go to program and there we go. Radical is about 173 bytes. Not much, but it's definitely not much if you have your calculators, like if you've never put a program in your calculator. So now let's test the program out. So press program, and now when you're not on the program ending screen, like this, and you can create a new program and stuff like that. So execute radical. Okay, and if you ever need to edit the program because you missed some kind of line of code, go to edit and then press the radical, and it will give you the line of code again. So so go to execute radical, and I'll say this, and I'll press enter again. All right, so what is R? So let's say R is 76. And there it is, folks. So the square root of 76, it'll do the factor trees and everything, 2 to the square root of 19. So it does everything correctly. All the logarithms are the same. When I enter everything, let's go down to the logarithm. Oh, wow, I already scrolled to. Yeah, right here. So 1 plus the initiative, or the integer of the logarithm of a. Now, 1 plus the integer of the logarithm a, we need a logarithm to, is basically what initiates a factor tree. And the factor tree will create like how many factors there are. And that's not what log does in like real life, but basically when you combine it with int, and the log will make find factors. It's very effective. So yeah, so second quit, and I think that about does it. So I'll put in a Word document about what's in about the whole code. Make sure that you can't edit it. It's in Google Drive. So thanks for watching. That's about it. That's how you make a program that simplifies radicals. So there's not much else more to say. Thanks for watching.